Okay, so today's notes are on solving systems with substitution. Our content objective is to solve linear systems algebraically using substitution, and our language objective is to use the correct terminology to correctly explain how to solve a system with substitution. Our first example asks, what is the solution of the system of equations? And gives us 3x plus 4y equals 12 and 2x plus y equals 10. So we're going to jump right in here. You may have done this before in Algebra 1 or in geometry in some other class. So maybe this is familiar and this is just a quick refresher, but if not, we're going to go through step by step to make sure you understand. Just a reminder, we're solving for the solution of a system, so we're solving for the point where these two lines intersect, so we're solving for the x and y value that will make both of these equations true. So we're searching for the x and y value that makes both of them true, which is the solution of the system. So we're going to start when we're doing substitution by isolating one variable from one of the equations. It will work no matter what variable you solve for, so make this really easy on yourself. Choose the simplest to solve for, or the easiest to solve for. So looking at these two equations, I'm going to label this equation 1 and this equation 2, so I can refer to them. Equation 1, both x and y have coefficients. Equation 2, y does not have a coefficient, so that means y is going to be easiest to solve for in this problem. So I'm not trying to put them both into slope-intercept form like we've done with a lot of our most recent lessons. Today, I'm just trying to isolate one of these variables to get it by itself. In this case, it happens to be y is easiest to solve for in this equation number 2. So if I take equation number 2, which is 2x plus y equals 10, all I have to do is subtract 2x from both sides, and I get y equals negative 2x plus 10. So now that I've isolated y, so I've completed my first step, I isolated one variable from one equation, I isolated y in this one, I'm going to substitute it into the other equation. So substitute the new equation or expression for your variable into the other equation. So what this looks like is I'm going to take my equation number 1, which is 3x plus 4y equals 12. And I'm going to substitute this whole thing in for y. So I'm taking the whole expression for y and substituting it into this y. So I'm going to have 3x plus 4 parentheses negative 2x plus 10 equals 12. So I've now substituted my expression for y into the other equation. So again, reminder, you have to plug it into the other equation. You can't plug it back into the same one, otherwise it's not going to take you anywhere. You're going to end up canceling things and not get any answers. So you need to plug it into the other equation, and then you're going to simplify and solve. So if you notice in this problem now, x is our only variable, so that's why we're using substitution. We can't get a numeric value for a variable unless it is the only variable. So I can't say x equals something unless x equals a number unless x is the only variable in that equation. So by replacing y with this expression that is in terms of x, I now have a new equation with only x as my variable. So that's ultimately the goal of substitution, is to get an equation in terms of one variable that you can then solve for. I emphasize that because we're going to get to some tricky ones later on in this unit. So when you're using substitution, your goal is to get one equation in terms of one variable. So then I'm just going to solve for the variable, as I said we would do here. So I distribute 4, I get 3x minus 8x plus 40 equals 12. I'm going to combine like terms. So I'm going to combine 3x and negative 8x. I get negative 5x plus 40 equals 12. I subtract 40 from both sides, and I get negative 5x equals negative 28. And then I'm going to divide everything by negative 5, and I get x equals positive 5 3/5, because 5 times 5 is 25. It's going to be positive, so 5 3/5, which I know you guys love decimals. I would say 5 3/5, but mixed numbers are also not written very nicely, so I'm going to say 5.6 for the sake of simplicity when writing, instead of using a large improper fraction for now. I know normally I say decimals are the devil, but for this one example, I'm going to use my decimal form so I don't have a mixed number. Next step, I'm going to substitute my new value. So I've now found x, but I need to find y. So y is the missing component in this solution set. So our solution, we have the x part, but we're missing the y. So I'm going to substitute this new value into any or either of the original equation. Either original equation to solve for y. So once you solve for the value of one variable, since there's only two variables in each of these equations, I can plug it into either one to get my y value. So I'm just going to plug it back into equation 2. So I'm going to say equation 2 is 2x plus y equals 10. I'm just going to take my 5.6 and plug it in for x. So I have 2 times 5.6 plus y equals 10. That becomes 11.2 plus y equals 10. Subtract 11.2 from both sides, and I get y equals negative 1.2. So then my last step, write the solution. So my solution is as a coordinate, includes both an x and a y value, so I need to write it as a coordinate point. So it's going to be 5.6 comma negative 1.2. If I was not sure, I could go back and plug it into my original equations and see that it works for both of them. But I know that it does in this situation, so I'm going to save us the time and tell us that it does work. But if you are ever unsure, you should plug it back into both original equations to check if it works. So I'm going to go through one quick check with you guys just to make sure we're on the same page. So I'm going to flip the page so I can write that down. I'm going to go through one quick check with you. Let's do this one. So I want you to solve for the solution of 2x plus y equals 20 and 6x minus 5y equals 12. So again, 2x plus y equals 20, that's a 0, and 6x minus 5y equals 12. Pause it, try it on your own. I'm going to go over it now. So in this problem, it's clear that y is going to be easiest to isolate since there's no coefficient. So if I rearrange that to solve for y, I subtract 2x from both sides. I get y equals negative 2x plus 20. And I'm going to substitute this in for y in this equation. So I have 6x minus 5 times negative 2x plus 20 equals 12. So again, I plug that into the y in this equation. And now I'm just going to solve for x. So I have 6x, I distribute my negative 5 into both parts, and I end up with positive 10x minus 100 equals 12. Combine my like terms, I get 16x minus 100 equals 12. I add 100 to both sides. I get 16x equals 112. Last step, divide by 16, and I get x equals 7. So I got my x value. Now I can just plug this back in for y up here. So I'm going to plug this back in. Y equals negative 2 times 7 plus 20. Y equals, so just to be clear, I plugged it all the way into the x value. Negative 14 plus 20. Y equals 6. So then I'm going to write my answer as a coordinate point. I get 7, 6. And that is my answer. All right, that's all for today. Make sure you write down any questions, comments, or concerns you have on substitution so we can go over them together in class.